Welcome to Young Tuition. Let's continue discussing basic issues in atmospherical physics that you may or may not know, but would be delighted to watch this short talk in plain language for ordinary people. Please like, make comment, subscribe, and activate your bell so that you wouldn't miss any development and dramas in my ongoing climate research. Greenhouse effect has been taught at schools, frequently heard in the mass media, superficially explained by many climate believers, and occasionally discussed by well-trained climate researchers and theoretical physicists. But what can you remember the most? The 33 Kelvin global warming by the greenhouse gases, the perfectly right CO2 concentration 300 ppm just before the Industrial Revolution, the stratospherical cooling predicted by Manabe and Verzerode in 1967, the runaway greenhouse effect advocated by James Hansen for his grandchildren. I will consider them all in light of the latest zero surface hypothesis, as you might have known by now. By the way, the zero surface radiation hypothesis is actually not merely a hypothesis. Rather, it is a direct corollary from the zeroth law of thermodynamics. So, are you ready? Let's go and have fun. In history, Fourier was one of the first thinkers who thought the apparent diurnal temperature difference between the Earth and the Moon might be due to the atmosphere. Instead of developing a thermodynamic model, he drew people's attention to a possible obscure radiation by the Earth's surface, apart from that from the Sun. Monsieur Fourier, beaucoup l'avez-vous, considère la voix, c'est la de boule en première lieu. In 1836, Fourier, another Frenchman, argued that the equilibrium temperature of the atmosphere must be higher than the temperature of outer space, but lower than the temperature of the Earth's surface, which is not true unless he meant the average temperature of the atmosphere. In 1861, Tyndall first observed the infrared absorption by gases in a pipe, including water vapor and CO2, by using boiling water as a source called the Leslie cube. All of a sudden, the radioactive transfer in the atmosphere had become the focus of the studying climate, while Fourier's thermo-insulated atmosphere was gradually forgotten. In particular, Tyndall's observation has been interpreted as a direct evidence for the atmospherical infrared absorption from the surface of the Earth, often called the terrestrial radiation, although the source was separated from the gas pipe in Tyndall's experiment. In other words, the gas and the infrared source had different temperatures. It is due to this subtle difference, I believe, that the time bomb was installed at the core of climate modeling by many. In 1896, Arrhenius proposed his climate model in line with this misconception by merely considering the so-called radiative equilibrium. To do so, he was obliged to physically separate the gaseous model atmosphere and the condensed matter surface of the Earth. As a result, he completely omitted thermal conduction, convection, and mass transfer between the surface and the atmosphere, as shown in this diagram. This is the first problem of the greenhouse effect hypothesis. As a result, it has been taken for granted by many climate researchers that the surface must constantly emit infrared radiation at the intensity around 390 watt per meter square, as a black body does, from which over 95% of the terrestrial radiation was assumed to be absorbed by water vapor, CO2, and ozone in the atmosphere, while the radiative equilibrium formulated by Arrhenius is called the greenhouse effect. These infrared absorbers in the atmosphere are now called the greenhouse gases. How does the greenhouse effect work? Here is a diagram from an online talk by Sara Harris, which represents the typical viewpoint of the consensus on this issue. First, Sara was correct to conclude the global mean surface temperature should be 278 Kelvin in the absence of the atmosphere by treating the Earth as a black body. Then, by adding a reflective layer, but without any infrared absorbers, hovering about the black body, she obtained the surface temperature would be 255 Kelvin. So far, this number, 255 Kelvin instead of 278 Kelvin, has been widely considered as the surface temperature in the absence of the greenhouse gases. This is the second problem of the greenhouse effect hypothesis. By adding the infrared absorbers, or the so-called greenhouse gases, it was argued by both Sara Harris and Sebine Hossenfelder that the CO2 can block the upward surface radiation and re-emit back to the surface. As a result, the cold surface could be heated up by the greenhouse gases. What a magical tale for children. So they claim quantitatively that the surface temperature would reach to exactly 288 Kelvin when the CO2 concentration was 300 ppm. This is known as greenhouse effect type 1, in which the CO2 concentration 300 ppm seems just perfect right in rising the surface temperature exactly by 33 Kelvin, together with water vapor, of course. This is the third problem of the greenhouse effect hypothesis. Based on this problematical idea, it was speculated that the radiative equilibrium in the climate system would be destroyed whenever the CO2 concentration in ppm is different from the magic number 300. This speculation is called greenhouse effect type 2. In history, both Arrhenius and Manabe, and of course his supervisor Witherald, were based on this idea to predict both the possible global warming and global cooling when the CO2 concentration is doubled or halved, respectively. What could happen to air temperature near the ground? I'm sure you must have been told many times 1.5 K, 3.6 K, or even 7 Kelvin by the end of this century. Or even recently, the Earth is getting boiling.
Has ended the era of global boiling has arrived.
But how did the climate researchers get these numbers? In short, based on stratospherical cooling. Back in the 1960s, it was first predicted by calculation by Manabe and Witherald that the stratosphere, which is above the troposphere, might become colder as the CO2 concentration increased over there. Hence, the term stratospherical cooling became a fashion. Even Freeman Dyson talked about it.
Well, the stratosphere cooling is something we really know a lot about, because that's easy to calculate. It's a direct effect of carbon dioxide, which cools the stratosphere just by radiation, independent of weather. And it's very large.
Although he distanced himself from this notion during his final years on this planet. Why cooling instead of warming? Well, they argued that if any atmospherical constituent emit, the space around them would become colder because some thermal energy is being sent away, although they didn't say where the thermal energy comes from. If it is true, the outgoing infrared radiation by our planet would be reduced because, according to Stefan Boltzmann law, the atmospheric radiation intensity is proportional to its temperature to the power of 4. This idea is indicated by the green curve here, which represents the outflow infrared radiation. But notice the electromagnetic waves are described as kind of a fluid in space, which is absurd, by the way. The tale continues. In a long run, an imbalance in the radiation in the stratosphere would occur above the troposphere, just the isothermic layer immediately above the troposphere. By treating electromagnetic waves as kind of moving heated fluid, of course, one could argue that the air temperature in the troposphere would increase because more incoming heated fluid than the outgoing fluid, as shown in this diagram. Nowadays, it is believed by many that the global warming between 2 and 7 Kelvin would be just a matter of time and humans' reaction. Furthermore, as the CO2 concentration continues increasing, there is another alarming scenario, namely the runway greenhouse effect. As you know, a runway in an airport is used for an airplane to take off from the ground to the sky. The runway used in front of the greenhouse effect here is a metaphor for extremely global warming due to increasing CO2 that might completely vaporize water in the ocean and turn the Earth into a Venus-like planet. Sounds horrible. Nevertheless, all of the predicted climate scenarios associated with either the radiative equilibrium or radiative imbalance have been formulated based on the strong and constant surface infrared radiation at its thermal equilibrium temperature. This would be true if, and only if, the condensed matter surface could be physically isolated from the emitting layer of the greenhouse gases, as Arrhenius suggested over a century ago. So, what are the repercussions when there is no such a surface radiation? First, without the surface radiation, therefore, it can be foreseen that the infrared absorption by the so-called greenhouse gases would be significantly reduced, no matter how much CO2 is in the atmosphere. Second, without the surface radiation upward all the time, the surface temperature can be stabilized with the least action, given the internal and external heat sources. Think about it. No radiation absorption by CO2 from the surface, no downward back radiation by the greenhouse gases. The efficiency of the climate system would be much higher, which would be the first choice by the nature. Recently, however, Sebine Hossenfelder told her viewers and fans that it is the absorbed infrared radiation by the greenhouse gases from the surface that can keep the surface warm and stable.
The incoming radiation from the sun goes through the atmosphere and hits the surface. It's converted into infrared radiation, and that heats the atmosphere from below.
But this can hardly be true. The troposphere is in fact warmed up by means of general circulation of the air. That is driven by gravity-constrained convection and pressure difference-driven advection. None of them are radiative processes. She might have convinced herself by analogy of colliery for heat and phlogiston for fire. Similarly, the runway greenhouse effect is as absurd as to use a paper bag to containing a fire. Even Sir John Houghton, the former chairman of the IPCC Scientific Advisory Group, thought it was unlikely. Third, return to the greenhouse effect type 1. If there is no surface infrared radiation, how can CO2 make the tropospheric warming by blocking nothing? This implies CO2 and other so-called greenhouse gases can hardly act like a blanket to keep the surface warm, just as one cannot keep his body warm in the winter night by hanging his blanket at the roof. Many people nowadays might have only thought of fishes in the water, but forgotten humans like fishes. We are also submerged in the sea of air rather than vacuum. Indeed, it is the nitrogen and oxygen molecules in the air layer physically attached to the surface that keep the surface temperature stable day and night. Fourth, let me talk about the predicted stratospherical cooling by Manabe and Wetherald. Recently, I have evaluated their published data and found the imbalance in the outgoing radiation is just 1.2 watt per meter square due to CO2 doubling, which is 3 times less than the value 3.7 watt per meter square used by the IPCC and many climate researchers. I will discuss this in detail soon. Basically, this implies either the CO2 concentration in the stratosphere or the CO2 emissivity was overestimated by Manabe and Wetherald. This new finding seems consistent with Manabe's recently remarks on the observed stratospherical cooling in the lower parts of the stratosphere, that the observed cooling could be partially due to ozone. Besides, to me, it would appear strange why there was no reported observation in the higher altitudes where the predicted stratospherical cooling is much more significantly large and hence easier to be measured. Fifth, using the original definition of radiative forcing, F equal to I sub S minus OLR, it is apparent that the radiative forcing would be always equal to the OLR, the outgoing long-wave radiation, in magnitude, though opposite in sign, when the surface radiation is 0, or the sum of radiative forcing and the OLR is 0. What does this mean? Simple. The so-called greenhouse effect simply denotes the total absorbed solar radiation by the atmosphere, including the solar radiation at the surface that is completely transformed into the internal thermal energy of the atmosphere by convection, conduction, and the mass transfer involving latent heat. Whenever the planet is overheated, the OLR is spontaneously turned on. So, no surface radiation blocking, no black radiation into the surface. Above all, the radiative forcing actually originates from the radiation by the sun rather than from the surface. If you could understand this logic, then you wouldn't have much trouble to explain those problems listed above. Problem 1, like other careless climate researchers, both Sebine and Sara made the same terrible mistake. How? Because they must have naively thought the real atmosphere and the surface could be physically separated, as Arrhenius first suggested. Problem 3, because they imagined global warming by the greenhouse effect type 1 is just 10 Kelvin rather than 33 Kelvin. To use CO2 concentration 300 ppm as a just right number is just a joke, isn't it? As I noticed that Sebine Hossenfelder has tried to make her talk humorous, I hope one day he would tell her fans that he was kidding. It's unlikely, though, as she has become a saleswoman rather than a professional researcher. In summary, the presence of the real atmosphere on the real surface implies they are at thermal equilibrium, which was first overlooked by Fourier in 1836 and climate researchers after him. No surface radiation appears as the natural choice for the climate stability. Any surplus in the infrared absorption by the atmosphere can be spontaneously emitted to space, rather than making the surface warmer. As I said earlier, no one can contain a fire by using a paper bag. Thank you for your viewing. Thank you for your donation. See you next time.